All right, this is 3.11 related rates, problem number 13. So you have a balloon, and it says it's spherical and is inflated, and its volume increases at the rate of 15 cubic inches per minute. So increases is a keyword, rate is a keyword, and that's the amount. So we're going to take that and change it into a calculus statement. So rate, when you see rate, hopefully you all see derivative. And when you think derivative, you should think a change in something over a change in something. So something's changing as something else changes. As you read this, something is changing in cubic inches as something else changes in minutes. And they tell you it's volume. So from that, you should see volume changes as time changes. And how much does it change? It's 15 cubic inches per minute. So in your brain, this should make sense. The change in volume is 15 cubic inches. The change in time is 1 minute. And why is it positive? Because the volume is increasing. Remember, if the derivative is positive, then the function it's the derivative of is increasing. If the derivative is negative, what it's the function that it's the derivative of is decreasing. And since they specifically tell you the volume's increasing, we know that's positive. So in your head, this balloon should be getting bigger and bigger and bigger. The next thing you see, what is the rate? Again, they're looking for the derivative of what? It's radius, the rate of change of the radius. So in your head, you should think, oh, I want the change in the radius as time goes on at a specific time. They say when the radius is 10 inches. And that's what we're looking for. And so once you have all the rates that are involved, what's changing, the things that are changing, you look at what's changing. The volume's changing and the radius is changing. So now you need an equation involving the volume and the radius. Well, good news, they will give you the formula on the AP test on this kind of a function. On basic ones, they won't, but on the more complicated ones, they will. So they will tell you the volume is 4/3 pi r cubed. Okay? Now is more thinking time. So t is our variable, right? T is the variable. There are no t's here. So how do you take the derivative when our variable doesn't even appear? Well, here's the next concept. V is a function. R is a function. Both of those change as time changes. The volume changes as time changes and the radius changes. So both of those are functions. So this is where the chain rule comes into effect. These are functions. These are box. You have to treat them as functions. So what's the derivative of this side with respect to time? Well, by definition, it is dv dt. Now 4/3 and pi, those are constants. They're not changing with time. Pi doesn't change, 4 doesn't change, 3 doesn't change. So I have a constant times a function. The constant remains. And r changed with time, so that's a function. It's a function cubed. What's the derivative of box cubed? It's going to be 3 box squared times the derivative of r. But by definition, derivative of r is dr dt. So that is our differential equation, and it's related rates. The rate of the volume and the rate of the radius, they're related to each other. They're connected. So that's why they're called related rates. But they want dr dt when r is 10 inches. So that's the specific condition. So that means we need dv dt when r equals 10 inches. and I have this. Well, R, we know, is 10 inches. And we want dr dt when R is 10. Now let's plug in more information. We know dv dt is 15. So we're going to take that 15 and plug it in for dv dt. 15 cubic inches per minute. And I'm going to multiply some of this out. So this 3 cancels. Oh, wait. Yeah, we're good. I thought I messed up. It cancels that 3. And then we're left with 4 and 10 squared. The 10 squared is 100. So that's going to be 400 pi. And it's going to be square inches because it's inches squared. And we're looking for dr dt. So let's start canceling things out. If I divide both sides by square inches, 2 square inches cancel out with 2 of those, leaving 1. Then I'm going to divide both sides by 400 pi. And all those cancel. And we have our final answer. dr dt when R is 10 inches is all of that. So on top we have 15 inches. On the bottom we have 400 pi minutes. All right, that's the answer. Now, how did I get this? Well, 15 inches are on top, the minutes on the bottom, and that's on the bottom. Now, if that confuses you, when you divide a fraction by a fraction, you multiply by the reciprocal. So basically, we multiply by 1 over 400 pi. So all those are on the bottom, and all that's on top. Now, let's think logically. Does it make sense that R is increasing because the rate's positive? It does, because if you're putting more air into the balloon's increasing. Now let's look at the units. The radius is increasing in inches per minute, which makes sense because the length of the radius would have the units of inches. So that is, yeah, that's the problem. We're done.